frequency and period of electrical signals could be measured using, especially an alternating electrical signal, can be measured using an oscilloscope. Alternating electrical signal is alternating current. And what happens is the poles reverse, the cathode and the anode, and so you've got positive electron flow, negative electron flow, and it sloshes back and forth. And so the current goes up and down, the voltage goes up to a peak and then reverses. And generally it looks like this. It's called a sine wave. Now this is an oscilloscope. Over here, this is a function generator. It produces a function, like, say, right now it's on a sine wave. If I move it to a triangular wave, what happens? Look what happens to the oscilloscope. As I go from a sine wave to a triangle wave, it puts out that triangle. As I go to a square wave, you can't see the vertical parts, but that's a square wave coming down, up. So you can get different types of functions. Let's look at this sine wave again. That's more like what you see with an AC alternating current. You can use this to measure the period. An oscilloscope does not change the signal, it just changes the way you look at it. It's like Google Maps. You can zoom in, and zoom out, you can move over, back, you can adjust the amplitude and the period so you can see it more easily. It doesn't change the signal, it just changes the way you read it. So let's see what we've got here. We've got a, let's see, we're running at a channel 2, we're running 1 volt peak to peak. Each of these divisions, I'm going to just adjust a little bit so it's easier to read, easier for me to get. I'm going to increase the amplitude. Each division is 1 volt. So that means I've got 1, 2, 3, 4, 5, 6 divisions. The peak to peak, we call peak to peak voltage, is 6 volts. Now the period is 1, 2, 3, 4 divisions. It starts here, comes back down. That's 1 complete cycle. It does another complete cycle. We've got over 2 complete cycles on here. 1, 2, 3, 4 divisions for 1 period. And we're on a half a second, a half a millisecond per division. Let's see, a half, 1, 1.5, 2. That's a 2 millisecond period. So let's show the equations to see how you get this. First is peak to peak voltage given by VPP, which sounds French, and it's in volts or millivolts. And to calculate the peak to peak voltage on the oscilloscope, it's equal to the number of divisions, vertical divisions, times the volts per division, which is that knob that you adjust. The one that said 1 volt per division. It tells you what the scale is. And remember, this is voltage, this is period. So in this case, the number of divisions was 6. Is that right? Let's see. 1, 2, 3, 4, 5, 6 divisions. So we had 6 vertical divisions on the oscilloscope. And it said on the scale, 1 volt, there was 1 volt per division. And I just adjusted that scale, and I can make it bigger or smaller. I just want to make it easy to read. I've got 6 volts, and that's peak to peak. Now for the period, period was the distance between the length of a cycle. I can measure it here, I can measure it here, I can measure it from the troughs or from the peaks. Either way, it doesn't matter. I'm just measuring a full cycle. So the period is a number of divisions times the time per division. In this case, the number of divisions from here to here was 4 divisions. I could have spread it out. I could have had 8. I would have had half the time though. So I've got 4 divisions, and I was looking at a half a millisecond per division. That's what the scale knob said. 4 times a half is 2. The divisions cancel. That gives me 2 milliseconds So the period is 2/1000ths of a second long. Now the frequency, what's that? Frequency is the inverse of the period, which is going to be 1 over 2, and instead of milli, because I've got to take into account that it's not a second, instead of milli, I'm going to write times 10 to the minus 3, because that's what a milli is, seconds. And I think I'll add, you know it's the period, so I'm just going to add seconds per cycle. Kind of redundant, but I'm going to flip it over and get cycles per second, which is frequency. And so this is going to give me, let's see, 0.5 times 10 to the 3, which is 500 cycles per second, which is 500 hertz. And you can check these out because you'll be using oscilloscopes. Let's go back here and see how well that works. Now I calculated 500 hertz based on the period here. But the function generator tells me the frequency. Now if I look at the function generator, I've set it on a range of 1K, 1,000, and it's set at 0.5. So it's 0.5 times 1,000. It's set at 500 hertz. So it matches. Two different ways of checking it.